We will be discussing fuels and combustion. Particularly, we will focus on ICE fuels. By definition, a fuel is any material that can be made to react with other substances so that it releases energy as heat energy or to be used for work. All fuels commonly used in ICE are products of crude petroleum. In general, crude petroleum are primarily carbon and hydrogen. The proportion is 86% carbon and 14% hydrogen in approximation. Okay, we have different types of IC fuels. We have liquid fuels and gaseous fuels. The most common liquid fuel we use includes gasoline and diesel fuel. While gaseous fuel, we use natural gas, propane, and butane or LPG. The gasoline is obtained by distillation of crude oil. Meron tayong apat na grade for gasoline. We have the regular, premium, unleaded, and super unleaded. The difference of these grades are the additives that they put on the gasoline. For example, in regular, okay, the regular gasoline contains tetraethyl lead to increase its knock quality. Tetraethyl lead serves as the anti-knock additive, so therefore increasing the octane rating. Okay, we will discuss naman yung term mamaya. Then premium, it contains larger quantity of tetraethyl lead. It has higher fuel. From the standpoint of distillation range and performance, it has a higher anti-knock rating and it is used for engines with higher compression ratio. Unleaded gasoline contains no tetraethyl lead because we know that lead is toxic substance, but instead of tetraethyl lead, we use methyl tertiary butyl ester as anti-knock agent, and it has high anti-knock quality. Lastly is super unleaded, higher octane rating that unleaded has larger quantity of anti-knock material. We have in diesel, we have 3 grades available for diesel, grade 1D, grade 2D, grade 4D. Itong grade 1D, it is the regular diesel and the grade 2D is premium diesel. Ito namang grade 4D, hindi natin commonly na ginagamit dito. Okay, yung grade 1D, yun nga, since regular, ito yung economy fuel, while the grade 2D stands for long distances. Grade 1D fuels are fuels applicable for high-speed engines with frequent relatively wide variation in loads and speed. They can be used in cases where abnormally low temperatures are encountered. While the grade 2D, the fuel oils has lower volatility. It means that it does not evaporate easily. It is applicable in high-speed engines in services involving relatively high loads and uniform speeds, or in the engines requiring fuels having higher volatility. The grade 4D, these fuels are applicable for low and medium speed engines employed in services involving sustained loads and substantially constant speed. We have this alcohol fuel. Alcohol fuels or alcohols are used also for internal combustion engine, particularly on spark ignition engines. Ang alcohol fuel that we use includes ethanol and methanol. The ethanol are obtained from green crops, green crops such as corn, wheat, and sorghums. Sugar crops such as sugarcane and sugar beets, starches such as potatoes, crop residual such as cornstalk, or which is known as grain alcohol. While the methanol is obtained from coal, natural gas, petroleum, or wood. It is commonly known as wood alcohol. The problem lang sa ethanol is nagko-compete siya sa food supply natin. Okay, the disadvantage of use of alcohol, mas mababa ang heating value. Yeah, it only have 67.5 of the heating value of gasoline. It does not vaporize readily. And yun nga, manufacturing cost and production is high. And then it is alcohol fuels are mixed with the gasoline. Gasohol yung term sa mixture of 90% unleaded gasoline and 10% alcohol used for spark ignition engines. Advantage of adding alcohol to gasoline. Tumataas yung octane rating ng fuel. It forms no soot or carbon in the engine, mas malinis. It burns without producing smoke or disagreeable odor. The exhaust is free nitrogen oxides without special cleanup devices because alcohol burns cooler. Cool burning reduces the possibility of burning bulbs, and the higher compression ratio can be utilized in an alcohol fuel, therefore the engine efficiency is higher. Next naman is we have the natural gas. Yan, as we discussed before, that natural gas is largely composed of methane gas. Natural gas is confined and in stationary power units which can be permanently connected to supply line. There is a need for equipment in a pressure regulator or control and mixing devices similar to carburetor. The butane and propane naman, or the LPG, are simple hydrocarbon of paraffin series. They become gases at normal atmospheric pressure and temperature. Yung compared sa methane, mas mababa ang compression ng butane and propane para ma-liquefy. But the purity propane and butane are stored in tanks with pressure so that in heavy tanks under large pressure. Ito yung fuel properties, yung mga terminologies, octane rating or octane number. It is the measure of gasoline's tendency to resist detonation during combustion engine. It means ito yung resistance niya from compression. Ibig sabihin, pag mas mataas ang octane rating ng gasoline, mas mataas ang performance and efficiency niya. While the knock, ito yung term kung saan merong pagputok or yung sound that varies with engine speed. It can be because the bearing are loose or worn, or it may be cause of detonation in the engine. While in detonation is spark, knock, or ping in the combustion engine. In the combustion chamber of a spark ignition engine, an uncontrolled explosion after the spark occurs in the spark plug. Yun yung uncontrolled explosion, yung tinatawag na detonation. The setting number or setting rating is the rating given to diesel fuels for their ability to burn without detonating. Ito yung nagme-measure ng ignition delay in an engine. Ibig sabihin, mas short ang ignition delay ng engine, mas mataas ang setting rating, and mas maganda ang performance ng engine. Viscosity naman, ito yung resistance to flow exhibited by a fluid. Ito yung pagka-thickness or stickiness ng fluid, yung pagkalapot niya. Gravity naman, the gravity of fuel is measured into API, devised by the American Petroleum Institute. May formula tayo na API degrees is equals to 141.5, yung constant, all over specific gravity at 60 degree Fahrenheit minus 131.5. Then, isa dito, ng API of water, APR of water is 10. The liquids lighter than water have the value above 10. Yung heating value naman, ito yung amount of heat or amount of energy that can be converted into work when burned in the engine. Yun yung heating value niya. And then the volatility, measure of the ease of vaporization. Mas mabilis mag-vaporize isang fluid, mas mataas ang volatility. Pour point and cloud point, ito yung the lowest temperature at which fuel ceases to flow is known as its pour point. The pour point specification should not be any lower than necessary because low pour point can be obtained only at the expense of lower setting numbers and higher volatility. Ito lang yung common properties of the tractor fuels. Meron tayong API gravity. Mataas ang API ng gravity ng propane. Pero mas mababa ang kanyang density. But mataas din yung energy mass niya. And then ito yung energy for volume. Simply yung pwede nyo siyang i-convert gamit yung density at saka heating value. Then the octane rating, mas mataas at the propane has the 100% octane rating. Then makikita natin dito, mas maganda rin ang performance ng premium gasoline, mas mataas ang kanyang API gravity, mas mataas din yung energy per mass na available, pero mas mababa ang density niya. Ayan. Same with regular gasoline. And diesel fuel naman, it is the average setting rating of diesel fuel is 55. And then ito yung range lang ng compression ratio ng different fuels. Next is combustion. When we burn carbon and hydrogen combined with oxygen, we will form heat resulting to pressure increase. Ito, sinabi dito yung property of air that the air is 23.1% of oxygen by weight and 76.9 nitrogen by weight. By volume naman, 20.8% yung volume ng air and 79.2% ang volume ng nitrogen. And then ito yung molecular elements niya. Carbon, 12, hydrogen, 1, 16, yung oxygen, nitrogen is 14, sulfur is 32. Then molecular weight naman. And then chemical formula for some fuels, we have the octane, C8H18, diesel or hexadecane, C16H34, ethane, C2H6, propane, C3H8, and sunod-sunod na yan, kerosene, di ba? And C12H26. Kung mapapansin natin yung pagkuha ng chemical formula ng hydrocarbons, for example, itong 8 times 2 plus 2 is 18. And then 16 times 2 plus 2 is 34. 2 times 2 plus 2 is equals to 6. Ganun yung pagkuha ng chemical formula niya. Para mas madaling matandaan. Bakit ba natin diniscuss yung mga chemical formulas? Ito ay gagamitin natin para sa air-fuel ratio. As for example, compute the air-fuel ratio of methane at standard condition. When burning methane, ang kailangan natin is oxygen, and then magiging product niya is carbon dioxide and water. Ito yung chemical equation natin, and then we must balance the equation. Makuha natin yung CH4 2O2 is equals to CO2 plus 2H2O. Sa pag-balance nito, yung hydrocarbons, yung muna natin pagbabasihan, punta natin yung 1 carbon lang, so 1 CO2, and then itong CH4, we have H2O 2 times 2, so 4. And then yung oxygen, ilan yung total oxygen dito? Ito isang O2, tapos ito O times 2, so 2O2. And then kunin natin yung atomic mass unit. Compute natin. Ayan. Yung carbon, we have 12. 12 yung atomic mass ng isang carbon. Tapos yung hydrogen is 1. Since apat siya, 1 times 4. Then oxygen, 16 times 2. 16 yung mass ng atomic mass ng oxygen and times 2. And then ayan. Ganun dito sa carbon dioxide and water. And then we will get ang atomic mass ng methane is 16. Ang atomic mass naman ng dalawang oxygen is 64. And then carbon dioxide 44 plus 36 naman yung water. Ang kailangan natin is air-fuel ratio. Kung i-add natin dito, ito yung fuel, ito yung oxygen. 64 over 16 is the oxygen fuel ratio. Pero rin nahanap natin air-fuel ratio. So, kukunin natin 64. Since ratio siya, ang sabi doon, 23.1% ang composition ng oxygen by weight sa air. Kaya kinuha natin 64 all over 0.231 all over 16. So, ibig sabihin, meron 277 kilogram. Kailangan natin 277 kilograms of air para magkaroon ng complete combustion sa 16 kilograms of fuel or 17.32 kilograms of air per kilogram of fuel. Another naman, aside from methane, gasoline naman. Ang chemical formula ng gasoline ay C8H18 and then plus oxygen is equals to carbon dioxide plus water. After nito, 8 yung carbon. So, magiging 8 CO2. And then yung hydrogen is 18. So, 18 over 2 is 9, kaya naging 9 H2O. Tapos, i-compute natin kung ilan lahat ng oxygen dito sa kabilang side. We have 2 times 8. 8 times 2 is equals to 16. Plus 9, 24. 25. And then, yun, since O2 to, 25 over 2 is 12.5 O2. And then, pag na-balance na natin yung equation, kunin natin yung atomic weight. Ayan. 12 times 8 sa carbon. 1 times 18 sa hydrogen. And then, ito, diniretso ko na yung 32 since 16 times 2. Tapos, ganun din sa carbon dioxide. And then, sa water. Pwede nyo yung gawin para mas simple. Then, makakuha tayo ng 114 ang atomic mass ng gasoline, and then 400 yung nakuha nating atomic mass ng oxygen. So, ibig sabihin, ang ratio niya is, kung oxygen fuel, 400 over 114, pero hinahanap natin air fuel, sabi natin kanina, 23.1% ang percentage ng oxygen sa air. So, makuha natin yung 400 all over 0.231 over 114. Nakuha natin is 15.19 over 1, or 15 kilograms of air is required for complete combustion of 1 kilogram of gasoline. Ayan, meron mga references kapag nagtingin kayo sa ibang reference, medyo may discrepancy sa air-fuel ratio kasi gumamit lang naman tayo ng rounded na atomic mass. Pero pagka gumamit tayo ng mga decimal, mas accurate yun. Pero yan, okay na naman yan. Yan na lang okay lang yan yung gamitin natin. Ito man another problem. I'm sure na na-discuss na sa thermodynamics nyo yung pagkuha ng mga thermal efficiency. I don't have to discuss it further. Yan, sabi dito, gasoline containing 98,000 BTU. Yun yung available energy to sa gasoline. And then, ang na-reject niya ay 69,000 BTU. Ang hinahanap ay network and thermal efficiency. Sa pagkuha ng network, QH minus QL, and the thermal efficiency is network over QH. Yan. So, nakakuha tayo ng 29,000 BTU yung work na na-produce or workout or output dun sa combustion, and then thermal efficiency niya is 29.6%. Another example, car engine with a power output of 65 horsepower has a thermal efficiency of 24%. Determine the fuel consumption of this car if the fuel has heating value of 19,000 BTU per pound mass. Sa mga ganitong problems, pwede kayong mag-derive ng units. Makukuha kayo ng formulas. Yan ang hinahanap ay fuel consumption rate or FCR, given ang power output na 65 horsepower, and then meron tayong 24% na thermal efficiency. Yan yung mga formulas na gagamitin natin. Okay. Hinahanap natin una is yung QH. Na-derive natin yung 11,486.04 BTU per minute. And then yung fuel consumption rate is equals to QH, or available energy, all over the heating value. So we get 0.605 pound mass per minute. And last problem, determine the power output of diesel engine with 32% thermal efficiency, and assuming that the fuel consumption rate is 2.5 liters per hour. So given yung thermal efficiency, given yung fuel consumption rate, ang hinahanap ay power output. So gamit yung thermal efficiency, makukuha tayo ng work net all over QH, or available energy. Pero ito lang yung given. So ito lang yung given, pwede tayong gumamit ng assumptions. Ito yung value of diesel, 45,460 kilojoules per kilogram, and then density of diesel is 0.85 kilograms per liter. Gamit to, makukuha natin yung itong 2.5 liters per hour, itong heating value and density, may makukuha na tayo. Yan, fuel consumption rate, convert lang yung liters per hour into kilograms per second. Or kinompute gamit ang density. And then, yung hinahanap natin is work net. Substitute na lang natin yung mga values. We get 8.59 kilowatts, or kapag tinanggal natin yung mga units, kilojoules per second or kilowatts, pag kinonvert natin into horsepower is 11.51 horsepower. And ayun lang naman. Thank you and God bless.